Hey AP Stats, Mr. Zmudio here, AP Stats lesson 1.3, and we are continuing with displaying categorical data. However, today's lesson we're going to be displaying categorical data for two variables. So we're going to be looking at two-way frequency tables, and we're going to try to interpret and analyze the data within the two-way frequency tables. So this term here, two-way frequency table, you may have heard that before, you may have not, but I'm pretty sure you have all seen these sorts of tables. That is kind of like the main vocab for today. A couple other important words. We're going to have marginal distribution. Oh man, that says distribution. And we have conditional distribution. All right, so two-way frequency tables, marginal distribution, and conditional distribution. So categorical data, think of these two-way tables as like you're asking a question that has categories as an answer. So for example, what is your eye color? It could be blue, brown, or let's go for this example. We'll say other. Right, so that's a categorical question, right? So for this specific variable of eye color, we have three different bins. We have blue, brown, and other. But I could also break this down further. If I was just talking about students in my class, I could also ask a second categorical question. For example, what is your sex? Is it male or female? So I can add a... I didn't give myself much space here. Let me erase that. Add a second variable here in sex and include male or female. And basically what this does is it lets us see how many of each type of variable there are. So let's say, for example, that we have 6 males that have blue eyes, 20 males that have brown eyes, and 6 males that have other eyes. 4 for this one, 16 for this one, and 12 for this one. So this right here, guys, is a two-way frequency table where you see two different categories, two different variables. So like we have eye color, we have sex, and within those we have different categories. So we have male and female, we have blue, brown, and other. So this is just your basic two-way frequency table. Now, remember I threw in this word marginal. Marginal. Think of what the word margins means. Margins, when we talk about paper, kind of means like the outside. Like, are your margins wide enough? So within a two-way frequency table, I want you to think of margins as like the outside. So all marginal frequency tables is I would add another column and another row. And this column and row would include totals. And you'll see what I mean here in a second. So the totals paints a nice picture. So if I total the males going across like this, I can see that 6 plus 20 plus 6 is 32 males. And similarly, I can do the same thing for the females going across. 4 plus 16 plus 12 will give us 32 females also. All right, if I add these two going down, I can see that I actually have 64 total kids that I interviewed for this display. And we can find the totals for the other variable, for the eye color. I can see that going down on this column, we have 10 students with blue eyes, we have 36 with brown eyes, and we have 18 with other colored eyes. So now that I added this extra column of totals and this extra row of totals, now this is a marginal two-way frequency table. Okay, so that word marginal, think of the margins, the outside. All right, so we'll come back to conditional here in a second. I want to let that sink in a little bit, and then we're actually going to answer a few questions that I think will help better explain the vocabulary here. So, two-way frequency table, marginal two-way frequency table. All right. So the first question I'm going to ask, and this is more of interpreting what's inside of the table. So what percent of females are brown-eyed? So what percent of females are brown-eyed? With stats, guys, a like little hint for you is whenever you see the word of, whatever that's followed by, so like in this case of females, that's going to be the bottom of your denominator. So for example, this is going to be a fraction. Females, how many total females do we have in this sample? We have 32 total females. So I know 32 is going to go on the bottom. And what percent of these 32 are brown-eyed? Well, of the 32 females, we have 16 out of 32, which you can put in your calculator or just recognize that that's 0.5, which is 50%. All right, that one seemed pretty obvious, right? But I'm going to show you a second question that looks very similar, but is not the same question. So what if I flipped brown-eyed and females? So what if I said what percent of brown-eyed students are female? So like I said, it's a nice little hint. Wherever you see the word of, that's going to be your denominator. So of brown-eyed students. Well, how many brown-eyed students do we have? We have 36 in total. And of those 36, how many of those are female? Well, that's just 16. So 16 out of 36. You can use your calculator for that to figure out that this percent is going to be about 44.4%. So notice two very different percents, and these two questions looked very similar, but they were actually very different questions. All right, and I'm going to give you a third question that also looks similar to these two, but is different. So what percent of all students are brown-eyed females? Okay, so what percent of all students? So I see of all students. So I know that we're actually looking at the total number as our denominator, which in this case is 64, right? And then the other thing are brown-eyed females. Well, how many brown-eyed females do we have? Well, looking over here, I see here's the brown-eyed column, And here's the brown-eyed females. We have 16 brown-eyed females. 16 brown-eyed females out of 64, which comes out to 0.25, which is 25%. So notice 3 questions look very similar, got very different answers. All right, so you should be copying this down in your notes. What I'm going to do here, so I don't have to keep referencing the top, is I'm actually going to erase this. You guys can continue, but I need a little more space and I want to quickly reference the table at the top. So number 4, let's go with what's the marginal distribution of eye color? So what is the marginal distribution of eye color? Well, like I said, when you see the word like margin, I want you to think of the outside. All right, so we're either going to be looking at this distribution, the column, or we're going to be looking at this distribution, the row. And the way you're going to know is it tells you what variable you're looking at. So you're looking at eye color. So here's the eye color. So here are all the totals of the different eye colors. So when it says what's the marginal distribution of eye color, it's just like asking what are the totals for all the different eye colors. And we can just say that by something like this. Well, for blue, we had 10 out of 64. For brown, we had 36 out of 64. And for other, we had 18 out of 64. So think about marginal distribution. You're either going to be looking at the totals on the bottom or the totals on the side, depending on what the question asked you. So I'm not going to write this question down, but think of this. If I had replaced eye color with sex, so what's the marginal distribution of sex? We would say males were 32 out of 64. Females were 32 out of 64. All right, and then the last question, which I hope hits on this last piece that we haven't talked about, conditional distribution. What's the conditional distribution of eye color for the males? All right, so the best way I can explain what conditional distribution is going to be is almost through an example. So conditional distribution is specifically when you're looking inside of your frequency table. So you're not looking at the margins anymore, but now you're looking inside at either a specific row or a specific column. And here's how we know. We're looking at the conditional distribution of eye color for the males. So for the males, that tells you what we want to be looking at. We want to be looking at all the males. And if I look at the males going across, Well, we had 6 males with blue eyes, we had 20 males with brown eyes, and 6 males with other colored eyes. And that's really all you're going to have to put down. We have blue being 6 out of 32 males. We have brown being 20 out of 32 males. And we have other being 6 out of 32. So what you should notice is that the conditional distribution, the denominator, it's never going to be as big as the marginal distribution, because the conditional distribution is only one of the categories, where the marginal distribution hits every single category. All right, that covers this lesson.